So far, we've learned how to find missing angles and sides using the tangent ratio. Now we're expanding to the other two ratios, which were sine and cosine. On the first day when we were talking about trigonometry, we talked about that the sine was the opposite over the hypotenuse, and that cosine was the adjacent over the hypotenuse. So what we're going to be focusing on in this video is, based on the information in the triangle, how do I find x? Looking at this example here, I'm going to model what to do, and then we're going to take some notes on the steps. So when I look at this picture here, I'm looking at what I know. I'm given an angle. I see that as 32 degrees. I'm given the side opposite, and I'm given the hypotenuse. So I think to myself, opposite, hypotenuse, that makes it sine. That's the biggest step in solving these. All of the mathematics and all of the steps are exactly like the tangent videos, and you'll see that as we go through. We're going to take some time to talk about the strategy. I'm going to talk through each of the steps in the flow map, and then if I were you, I would pause the video to take these steps down. Step 1 is exactly what I did in the first problem. I looked at the picture and I determined what I already knew. What sides did I know? What angles did I know? In some problems you're going to know one side and one angle. In some problems you're going to know both sides and no angle. So just have to pay attention to what you're given. In the second step, I'm introducing a little slogan that I actually used in school that I still think is very helpful, which is using Sohcahtoa. Sohcahtoa, and I'll show you in just a second, stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. It's a cool little mnemonic device that helps you remember what to do. And then the last step is just to solve like the tangent ratio questions. Solve it just like we did with some of the ones where we had missing angles and missing sides. Like I said earlier, I would pause the video at this point and jot down these steps. Let's take a look, first of all, to where I got Sohcahtoa from, because a lot of times students wonder where I came up with this. I didn't come up with this. This was just something I learned in high school and I still use to this day. So when I take a look at Sohcahtoa, it comes from the first initial of each of the different trig ratios. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So Sohcahtoa. Let's take a look at an example, and let's just go through the steps in the flow map. So step 1 is to take a look at what we have. When I look at this picture here, it's pretty much identical to the first picture we saw. We have an angle, we have the side opposite, and we have the hypotenuse. So when I take a look at this, if I've got opposite, I've got hypotenuse, I'm talking about the sine. So when I set up my equation, I'm going to set it up just like with tangent, except I'm going to use sine instead of tangent. So the sine of 42 is equal to x over 24. Just like with the tangent ratio, we are going to cross multiply. When we have x as our numerator, these are the questions that are easier to solve, because all I have to do is multiply. I'm going to multiply sine of 42 times 24, which is equal to x, and find out that the length is 16 and 6/100. Just like we did with the Pythagorean theorem, we like to round to the hundredths place, and that's typically on gridded responses what they will round to. Let's take a look at another example and see if we can identify the ratio. That's really where it's going to be key. In this problem, I can already see I don't have an angle. So I know I'm going to be doing some inverse of either sine, cosine, or tangent. Looking at my angle theta, I see I have the side adjacent, and I have the side that's the hypotenuse. So adjacent over hypotenuse gives me cosine. When I set up my problem, I know that the cosine of theta is equal to 8 over 10. When we need to find the angle, we need to do the inverse of the trig ratio. So instead of typing cosine, we're going to type second cosine in our calculators. Always a good point right now, in case you haven't looked before, definitely make sure you are in degrees. When I find the inverse cosine of 8 over 10, I come up with that the theta is 37 degrees. So we looked at one that was a missing side, where I used sine. I'm looking at one that's a missing angle, they used cosine. If you feel like you understand how I set up these two, when I go to the next problem, try to pause it before I go over how to do it. I will wait a few seconds as well. So take a second and see if you can set this one up and choose the right ratio. So taking a look at this question, I have an angle, I have the adjacent side, and I have the hypotenuse. So adjacent over hypotenuse gives me cosine. So the cosine of 24 is equal to 14 over x. This is the cross multiplying that students sometimes mess up with because we're going to have to do some division. Cosine 24, remember, it's just one number, x equals 14. We divide both sides by cosine 24. We come up with that x is equal to 15 and 32/100ths. Like with previous videos, I'm going to ask you to be able to find x and y. We're also going to have a discussion about multiple ways to solve, because there really are multiple ways to solve these questions based on what we already know about right triangles.